first things first. There we go. Oh, you make me angry if you didn't get 45 right through the glowing power of the graphing calculator. But I will say there is a way to algebraically do this to understand. Actually, not that when I found out what ended up happening, because you end up with an x cubed out of this if you did this. But you have to know what a negative exponent means if you wanted to try to approach this algebraically. When I have a binomial raised to the negative first, it's 1 over the binomial raised to the positive first. And then only this x has a negative first on it, so it's 1 over x plus x on the right side. The way you can approach this algebraically is multiply both sides by the LCD. This is part of section A3. I don't think we did that, solving rational function equations. I think we'll hit that in chapter 2. But even with that being the case, you end up with an x to the third, and it still ends up being a graphing calculator question that can't be done algebraically. So let's go back up to here. Everyone in this class should have got this right. Everybody. There's no excuse for it. I'm done. Drawing a line in the sand. I asked how many people got 45 right last hour, and 5 people raised their hand. That's a failure. Okay, so I'm starting to get where we got to start doing a better job. We just got to start figuring out what we do on a daily basis, and you as an individual need to figure it out. All right? So with that being said, this is why. All you had to do was, as it is, exactly as it looks, you type in the left side in Y1 and the right side in Y2. What I will talk about, though, is some things you should remember from last year. Okay, now I know when you were doing your homework you wouldn't think of this, but think of it now. What can I expect as a picture? Remember I said don't be a button pusher. You know, be someone that, okay, when I type this, this is what I think I should see. Do you remember this from last year? This starts with an A. It sounds like a naughty word. An asymptote. This has an asymptote at x equals -1, a vertical line, which is not a function. Tie back to what someone said earlier. So this has a vertical asymptote at x equals -1 because you can't plug in -1 for x. Why? This really ties into what we're doing today. Why can't you plug in -1 for x? What happens? You get a 0 in the denominator. Okay, then look at this. Even this side, even with that plus x, what can't you plug in for x on the right side? 0, because you get a 0 in the denominator. So this right side has an asymptote at x equals 0. Vertical line, which is the y-axis. There's also horizontal asymptotes for these. And we're going to have a huge section in that. Chapter 2 takes care of all of this again. But it should be 100% review for you guys with that. You should remember all these vertical and horizontal asymptote rules, and it should be review. So when I look at the graph, this is still why no one should have missed this. What do I see? I see 2 weird graphs, but at least they what? At least they what, which is what the lesson was all about yesterday. They what? Intersect, and it's obvious where they do. Okay, it's right there. So all I had to do was hit second calculate. This should have been one of the easiest questions on the on the homework. Boom, boom, boom. I'm saying, where is that arrow at right now? I don't really care. Just get it close to where they intersect by the left-right moves. Hit enter 3 times. So the answer for x is -1.47. I'm not even going to agitate myself by asking how many people got that right. This needs to get done. And many things need to get done on a daily basis, figuring out these easy things. But I will continue to blabber. Okay? The first graph is this one. It's hard to disseminate these two. The one that I'm tracing there to there. The reason I know that is that's -1 for x. And there's that x equals -1 asymptote. This is the second graph. There's a reason why this happens, but we'll talk about that later. Because this graph turns and then goes up and approaches the y-axis, turns and approaches the y-axis down here. That proves the y-axis is a vertical asymptote for that second graph. The only reason I bring that up is, what you need to know as a student is this window good enough? Do these graphs intersect up here anywhere? Well, knowing that this is a vertical asymptote, it's impossible. And knowing about horizontal asymptotes, that this graph doesn't come back up and hit this one. This one doesn't come back down and hit this one. Knowing about the graphs tells you that you have everything that's going to happen here. You know that these two are not going to do anything goofy to intersect. This is not going to curve back up and intersect there. Blah, 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 blah. Okay, so knowing what you're looking at is a key. All right, let's go get that homework. I'm okay. Okay, here's some things. I'm just going to ignore the directions. Here's some mathematical skills. That's why it's called quick review for 1-2. Hey, that rhymes. For things that you need to not make mistakes on. Okay, and it's your job to focus 100% through all the notes. It's almost physically and mentally impossible, but do the best you can. You know, it's hard. Okay, I swear to dog, if you make this mistake again, get out. Go sit in the weeds. X squared minus 16. What are the answers? Plus or minus 4. And the reason I say that so meanly on YouTube is I've said this a billion times, and I still have students putting their hand in the fire and doing what? Getting burnt. Okay, so what's this other one? 2. Plus or minus 3. You got thrown off a little bit by the minus x squared. I don't really care about this one. You just add 10. But this one, for number 4, I probably could move in on these, and then you could see them individually. And I think back in the day, I had students put them up on the board. We don't have time. I have a lot of stuff to go through. These are things you should already remember and focus and not make mistakes on them. And I'm going to give you the reason why this happens. So first of all, I might subtract 5. Someone might add x to both sides. You'd be better off. But if I decide to subtract 5, what do I have to do next? Now, what happens? Now, sometimes you guys are robots, and I just do that because my teacher told me. I always like to tell you where things come from. Whether that bores you or not, I really don't care. What's the relationship between 6 and negative 5? Is 6 greater than or less than? Well, that's easy, right? What if I do something silly and say, you know what? I'm a weirdo. I want to divide both sides of this inequality by a negative. What's 6 divided by negative 1? What's negative divided by a negative? What just happened to the relationship of the numbers? It's switched. What is x? A number in disguise. So it must follow the rules of numbers. When you divide by a negative, the inequality relationship flips by definition of how numbers work. There. Okay, now, let's just turn this into this. We're going to get a lot of these algebra skills out of the way. This is for domain, by the way. When I say domain, what letter are you usually dealing with? X. When I say range, what letter are you dealing with? Y. You get it. So these are going to be like domain questions. But all I'm going to ask you is, what can I plug in for x? For number 5. 16. Here's the reason. If I plugged in 16, I'd get 16 over 0. Remember grade school? Who goes in the garage? 16. Who goes outside the garage? What times 0 equals 16? Nothing. So in number 5, x cannot equal 16 because the function does not produce a valid output value, which is range. No valid output value, I can't plug in that value for x. Very simple. Now again, this is where I want to punch the thing right here. If you keep making this mistake, what can't I plug in for x in the next one? Not 4. Plus or minus 4. I heard someone say 4. Burn, burn, burn. So that's a more complicated domain issue. So therefore, don't make the plus minus mistake when you're finding domain. All right? All right. Now it's going to ratchet up. Am I going too fast? Good. Ooh, the writing is kicking in here. Okay. Now, we had a lot of good discussions. I think I just ripped on second hour about their not getting that one question right, like 5 people total. But we had a really good question about this, and I'm just going to cover it now. We are talking about a real coordinate plane. So we must keep the output values real. Why did I just bring that up for number 7? Because you could have the square root of a what? Negative if you put input values in. And I can't have that. You have to graph this in a real coordinate plane, a real x and y axis. So I have a question. Can I plug in 16? Yes or no? Can I plug in 16 for number 7? Yes, because what's 16 minus 16? What's the square root of 0? I get a valid output value. For the graph, it would have the coordinate 16 comma 0. That's what graphing is. Input, output. Can I plug in 17, 18, 19? Can I plug in 15? 15 makes it not a real number. So how do I write that as an inequality? X can be what? Greater than or equal to what? 16. Now this one's strange. I have a square root with a denominator issue. You have to take them both and then put it all together, and then it gets real complicated with 9. 9's the worst one of them all. But let's go back to 8. And again, you got to focus. This is all lecture because we got a lot of stuff. So let's think about it. You can't take the square root of a what? Negative, right? But what happens when you square a number when you throw it in and then square it? What happens every single time? You get a positive. So are there any issues for the numerator? Yes or no? No, no way at all. Okay, so now let's move to the denominator. I swear to dog, don't make this mistake. What can't I plug in for x? Plus or minus 1. No issues in the numerator, 2 issues in the denominator. And then we'll turn this into how we have to answer these questions later. All right, you focusing? You better be. All right. Now we got some major issues. This one really comes into play where you have to analyze the numerator and denominator and then put it all together. This one's crazy. Now I should pick on people, but I'm not. Let's do the numerators issues. Can I plug in negative 2? Yes. Why? What's negative 2 plus 2? What's the square root of 0? Can I have 0 in the numerator? By the way, the old grade school, 0 over any number. Let's just say 7. 0 goes on the inside, 7 goes on the outside. What times 7 equals 0? 0. That's why that has an output answer. So when I plug in negative 2, I get 0 as an output. So it's valid. Can I plug in negative 3? Negative 4? Negative 5? Negative 1? Negative 1, 0. 1, 2, 3. You haven't said one word yet. 4. Thank you. All right. So now what does that mean as an inequality for the numerator only? X has to be what for to get valid output values? Greater than or equal to what? Negative 2, not negative 1. Whoever just said that, you just ignored an infinite amount of numbers between negative 1 and negative 2 that work. And actually, that doesn't really apply to this. You can plug in negative 2 anyway, so got to make sure we understand that. Next. Oh, he's so mean today. What about this? Again, I don't want to teach you like this is what you do when you have a square root. You do this math. You got to think, man. Woman or whatever. Can I plug in 3? Yes or no? Careful. Oh, but can I? No, why? What happens when you plug in 3? 0 in the what? Denominator. So that's why that's different than the numerator. Watch it, right? So you can't plug in 3. Excuse me. Can I plug in 4, 5, 6? Can I plug in 4, 5, 6? No, why? What does it give you? Negative imaginary number. Some people aren't focused, not answering and not listening. Okay, that's fine. You all right? Good. Can I plug in 2, 1, 0, negative 1? Yes. So how do I express that as an inequality? X has to be what? So is it less than or greater than? Less than and less than who? 3. Don't say 2. Some people like to say 2. They skip all the numbers. Can I plug in 2.999999? Yes, 3 minus 2.999 is a positive decimal. Square root that positive decimal. You got a number. You have an output value. Here's the problem. How do I put all this together? I need to have this and that. I need them both to be true. So what does that mean as an inequality? So we got it offline. I had a student answer it. He tried to start with 3 is greater than x, but you always have to number the or list them in order of the number line. So if you look at these two inequalities, x has to be between -2 and 3, not including 3 though. So that's how you write it. You write it as an in-betweener right there. And in this, I'm going to have you reach back to your Math 3. And I know in Math 3, you actually did this quite a bit. So I know this is something that you should have recall from. Before we do any analysis on this, I am going to do this. Pull out an x. Shouldn't have to teach factoring anymore. Actually done it quite a bit. And then difference of two squares. Right? Factoring that just to see. Now, what do you see happens? I bet you did this last year. These cancel, but before you cancel them, I have a question. I always find this very interesting. What's 0 divided by 0? Oh, boy. I get a 1. Anyone else have anything else? Undefined. What's another possibility? 3 valid answers. The one thing is weird, though. 0 divided by 0 equals 1. Not going to do it. I would understand why a student might say 0 and a student might say undefined. And actually, this is one that you're going to have to lock in. You have divided by 0. What's the rule by that? It's undefined. This equals undefined. My grade school putting in the garage and out of the garage kind of doesn't work for this one either. You have to understand that that is undefined. So the reason I say that is, what happens when I plug in 2 for x? What's 2 minus 2? 0 times 2, because I plugged in 2 for x. 0 over 2 minus 2, which is 0 times 4. You get 0 over 0, which is still what? Undefined. So even though that cancels, this cannot equal 2. Doesn't matter. Then you'll remember, if I graph this, this is a hole. He got it. He got it. I just said, this is a hole in the graph. Do you remember holes? Remember drawing a graph, but you had to put a hole in the undefined value that where the things canceled out? All right, but also, what else can't x equal? Okay, so I wanted to show that just to make sure you remembered from back in the day. All right. I asked everyone to just walk around the room to get their blood flowing. Half the class revolted, so now I'm going to revolt against them. I don't get mad, I get even. All right, now mark this down. You could probably put this down for today. Obviously, I talked about domain and range already, but it's going to be more complicated. So we're going to do 3 things. Number 1 is we're going to determine function or not a function. Number 2, we're going to talk about domain. Number 3, we're going to make it to range, I hope. And that's it for today. Analysis of functions. So this first thing looks crummy, but actually it's pretty good what the book does here. And then I'm going to give you the simplistic definition of what a function is based off of what the student said at the beginning of the hour. I really like to keep this simplistic. What is a function? It is any equation or list of coordinates even, just a list of coordinates, where there is absolutely positively no repeating, what did we say? X. Or domain, if you want to put that in there, because usually X is domain. I should really say domain, because it's not always X and Y. Sometimes you have equations defined with different variables. What you really have to focus on is what I highlighted from the book. Maybe rewrite their definition. I remember as a kid, when I heard what a function was, like, that seems unclear. Is it no repeating X's or no repeating Y's? It's no repeating X's. But one other thing is domain is usually X, but it definitely is the input value. You input something and you get an output, and that's the range. Perfect functional situation is anyone that has a job that gets paid hourly. I work X amount of hours, I make Y amount of dollars, right? Dependent, independent. The range depends upon the domain. It depends upon how much money I make, depends upon how many hours I work. There's a perfect function relationship. Blah, 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 blah. What these are are mappings. All this is could be written in coordinate form. x2 comma y2, x1 comma y1, x3 comma y3. Oh, but x4 comma y3. There's only 4 coordinates in this relation. Is it a function? Yes. Now you got to remember from chapter 4 and trig. Chapter 4 and trig, we do have a 2-time and no good repeating y value. All that meant is it's not 1-to-1. And we talked about that when we did actually inverses of trig functions. But when we look at this one, we can see that x1 comma y1, x1 comma y3. We have a 2-time and no good x value. Therefore, this is not a function. Some other things to be aware of. Well, equations. How do I determine if I have an equation, if it's a function or not? You got to have a brain, a mathematical brain, and think mathematically of the things that you've learned. Like, for instance, what's this a picture of? See, to not know that real fast is a problem. What's that a picture of? It's a line. What's the slope of that line? Be careful. 2. What's the y-intercept of that line? 4. So if you look at this picture, again, if you don't know that, that is a problem. You are behind. Well, I'm in front of you for the second. I'll be moving. I literally was in front of a student for 0.5 seconds. I can't see. I can't see. Is that a function? Yes or no? Do I have any repeating x values? Yes or no? What test can show that I have no repeating x values? Okay, now you just probably sprout that out as I learned a vertical line test. And if a vertical line only crosses the graph once, all the vertical lines only cross it only once, or less, could be 0, then it's a function. But here's why. This particular x value only happens what? Once. Okay, right? That's why the vertical line test works. Is it 1-to-1? What line test can tell me if it's 1-to-1? We talked about that before. How many times does each horizontal line cross? Once. There's also no repeating y's. So the no repeating x's is it is a function. Oh gosh, that end got destroyed. And the green lines mean it's 1-to-1. Very simple. How do I assess that with an equation? Think about it. Maybe graph it or put in some coordinates. Do something. Who knows what the second graph is? Ooh, it is a parabola. But here's the kicker. Which direction? Sideways. I'm going to prove it. I'm going to pick a coordinate that I can plug in for x and solve for y. By the way, this is a game you can play at lunch. Put an equation on a piece of paper, pass it to your friend. Function, not a function. Think about it. Oh, sorry. Right? Divide by 2, right? Now I swear to dog. What does y equal? Plus or minus what? Yeah, I thought you said 4. Yeah. Okay, so I plugged in 4 for x. I got 2 for y, and I got negative 2 for y. What does that denote? A 2-timing, no good, what? X value. No one, I don't know if anyone said that. 4 happens twice. It happens with 2, and it happens with negative 2. If I did the vertical line test right now, it would what? Fail. But I wanted to plug in one more coordinate, just to bore you. What happens if I plugged in negative 4 for what? X? What happens with this one? I did this on purpose to get you to see what this picture looks like, just by connecting some points. What happens when you add 4? 0. You get 0. What happens when you divide by 2? What's the square root of 0? Nope. 0. Here's the vertex. This is a parabola going to the right. Just by plugging in 2 points for x, one of them giving me 2 y values. So you can see this fails the vertical line test, which denotes that 4 repeats. That's the anti-definition of a function. So again, I remember this being tough. It actually is not. If you could just hold down the fort on understanding domain does not repeat for something to be a function. And then, of course, this could be easy. Look at in exercises 5 through 8. I've constructed these notes way back when to follow with your homework. I don't care. I think that's a good way of doing it. If someone else says different, you know what, the heck with them. I think they do a good job. If they do something different, I think I'm doing fine too. So vertical line tests. Do you have to write these down as notes? Function, not a function. See, pass your friend a picture of a graph. Function, not a function. And then yell at them if they're not done with the answer in 0.5 seconds. Function, not a function. Function, not a function. Ah, this is actually real bad. This is a 3-timer. Look at -1. -1's a 3-timer. That's like a Jerry Springer show. All right, let's move on. Oh, you guys already know who Jerry Springer is, do you? Actually, he still exists. Okay. Number 2 for the day. Finding the domain. We already did that with the bell work thing. Now you should be trained professionals. Although 16 is tough, and I'm going to yell at you again. I do have your test graded. And actually, that was okay. But how we have to do this is a way that you guys, many of you messed up on the number line check. And solving an inequality. Wasn't too good. Okay, so, let's go back. So look at exercise 9 through 16. Find the domain of a function. When they ask you that, that means this. I wrote that down back in the day. Finding the domain means, what can I plug in for x for the function to either be defined or real, right? So we talked about in the bell work. I can't have the square root of a negative in a real coordinate plane. It just won't graph in a real coordinate plane. I guess is one way to think of it. So the first one should be the easiest thing in the world. Easy. And then I'm going to talk about your Math 2, Math 3. Actually, Math 2, Math 3, I think you covered this way. But have you ever seen an inequality like this? You get these little braces, X line, right? That I used to call that the Algebra 2 way of answering what is the domain. D colon, the domain is all x's such that. That's what that translates to. It's just a bunch of fancy mumbo jumbo. Okay, now, what can x equal? Very simple. If you don't know it, I can't deal with you. X can equal what? 3, because you can't have a 0 in the denominator. Back in the day, that was sufficient. This not equal to sign means it doesn't equal 3, but it equals everything else but that. That's what a not equal to sign actually means. It's nice. You have to put this in cat notation. So how do I not equal 3? If it's everything else but 3, it's that. What's that? I'm pointing to the left wall. Negative infinity all the way to not who. So what do I have to put around 3? Parenthesis. I heard someone say a bracket. Get that out of your brain. But then what do I union that? I got to get all the numbers after 3. So I have to start another one at 3 to infinity. So your cat answer is, and this is kind of annoying, when you have a not equal to sign, you have to write negative infinity to infinity, but then you got to exclude that one number by doing what we did here. In parentheses, exclude it. So that is the domain. Oh, I love this issue. And then you know why? That's what are you going to see in this graph? You should know this from last year. A vertical asymptote. There's going to be a vertical interruption in the graph. And the graph's going to behave a certain way to that vertical asymptote. You did that last year. We're going to do it a lot this year as well. Okay. This goes to that number 9 in the bell work. You probably didn't number them, but we really have to slow down and take this apart. We got to say, all right, I have some domain issues in the numerator, and I have some domain issues in the denominator. And then what I have to do is put these two together and figure out what the overall domain is. That's really how you have to take care of a fraction like this. But this is interesting. And again, I could show you a mathematical structure to do for a square root. And then what I might get is robots. Oh, when I do square roots, I have to do this method. It's not good. Think. Can I plug in 0? Yes or no? Let's just talk about the numerator. Let's not look at the denominator for a second. Can I plug in 0? Yes or no? Can I plug in 1 and or negative 1? Yes. Can I plug in 2 or negative 2? Oh, I get it. No and a yes. That's okay. The answer is yes. Why? You could have the square root of 0 in the numerator. Now, can I plug in anything after 2 or before negative 2? That's when you start getting square roots of negatives. How do I write that? You're the pro at this. Everything between 2 and negative 2. Oh, I don't know if you were paying attention. I thought. So it's. Actually, you know what? Let's just go to cat right now. Can I plug in negative 2? Yes or no? What do I put on it? Bracket. Can I plug in 2? Yes. And then what do I put on that? You got that down? Oh! Wow. Interesting. Okay, now let's look at the denominator. I just saw you not paying attention. I found it interesting. You didn't have notes either. Oh, I forgot. He hates me. I just made it worse. All right. What about the denominator? What can't x equal? This is the simplest thing. Let's just write it that way, because let's be honest. The negative infinity to 3 thing, and let's also think about it anyway. Did x equal 3 in the numerator restrictions anyway? Could it? No, so this is like it's already can't equal 3 up here, so this didn't really cause any problems. Where it would cause problems is, what if this said x minus 1? Ooh, this is good. What if this said x minus 1? What can't x equal? Right. So, I don't know why I did that. Then, is 1 in this list, yes or no? Okay, so let's just talk about that. I'll verbalize it. The domain would be then negative 2 to 1, 1 on a parenthesis, union 1 to 2. Both 2 and negative 2 would have a bracket. But with this being the case, this is already excluded from the red, the numerators. So the domain is negative 2 to 2 overall. And then you'll find out when you actually graph this thing, if you were to graph it, on the coordinate plane, there would only be a picture between 2 and negative 2. There'd be nothing over here and nothing over here, because the graph doesn't exist. It'd be some weird picture in between negative 2 and 2. We actually could plug in some points for that and figure out what it would look like, but we're not going to. Okay, then this last one, this is a bugger. Showed a method for this, and then what ended up happening is the robots try to use a method for all, and you just got to think. Okay, what can't you take the square root of? A negative. What is the definition of positive? Numbers that are greater than 0. Can I take the square root of 0? Yes or no? Yes. So wouldn't you agree that this expression without the square root has to be greater than or equal to 0 then? Right? Very simple progression. So really what I have to do is yank this out and say to myself, okay, I cannot take the square root of negative, so this has to be greater than 0, whatever I plug in for x. But I can't take the square root of 0, so it could also be equal to it. And then this is where I'm going to yell at you, those that didn't do this right, because it's going to be a big time part of your math coming up in Chapter 2. How do I solve this? I factor. I'm not doing factoring with you. You know what? I'm just going to put it equal to 0. And I don't know if this confused people or not. What you do is analyze inequality at the end. All I want are the critical numbers. By the way, this factors. What are the critical values? The zeros, if you will. The roots, if you have you ever heard the word root? That's another word for 0. Mark it down so I don't get in trouble for not giving you that vocab word. All right. So this is what we do next. What do we get for this critical value? A lot of people ignore this. 0. What do we get for this critical value? 4. What do we get for this critical value? And then what do we do about it? I check. I actually don't have to do this with a graphing calculator or any calculator. Watch what I do. I plug in... By the way, stop. Can I plug in -4 and get a valid output value? Why? It's called a what? 0. And you can take the square root of 0, so we better color that in. Can I plug in 0? Yes. Can I plug in 4? Yes. So assess that as well. I could do one minor change to this to really jack up the game. If I made this 1 over that, what would all these dots become? They'd be open, because those would be 1 over zeros now, right? So that was a nifty little thing I didn't do second hour. That's fine. Okay, now, -5. Very easy. What's -5 squared? 25. Isn't this 25 times 25 then? Minus 16 times 25? Because -5 squared is 25. Is this positive or negative when you subtract? Come on, 25 times 25 is bigger than 16 times 25, right? So, does it work? Yes, that means all numbers before -4 work. What's an easy number between -4 and 0? -1. And by the way, whatever you do for -1 will work for 1. Just like 4. Actually 5 I meant. Wouldn't 5 squared be the same as -5 squared into the 4th? Wouldn't you get the same thing? So we actually could kill 2 birds with 1 stone on that one. Because you have a squared and a 4th. You get the same output values. But -1 would be the same as if I plugged in 1. So I'm checking these as well. -1 to the 4th is 1. -1 squared is 1. What's 1 minus 16? What kind of number is that? That's a false. Now all you have to do is turn this into interval notation. What is the domain? -infinity. Whoa, that infinity got distorted. To what? What? What do I put on it? Bracket. Union. Now, this is funny. This is a Mr. Samuelis number. All by itself. What do I put around that? I think it's a bracket. I don't think you could be wrong. It just says 0. 0 is in. 0 is in. Yeehaw. And then union that with 4 to infinity. Oh, whew. All right. Let's move on to range. Whew. You want to get up again? No, 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 no. So now we're going to go on to range. This is infinitely tougher. Not infinitely. I don't want to make it scary. But this is a lot tougher to analyze. You need to get up. Range means what? Y. So when you throw in x values, what kind of y's do you get? Now, here we go. You all right, Luke? Ah, I almost said your name. You could have sued me. I stopped. Let's do this first one and use your brain. First of all, for number 8, by what? For number 8, let's go up here, and then I'll show you all the stuff that I wrote for it. This is right around where we got for second hour. We actually finished this one. What's the domain for number 5? Because then if we think about the domain, it may help us to find the range. Can I plug in 4, everybody? Yes or no? Yes. Can I plug in 5? No. Can I plug in 3? 2? 1? Blast off. So wouldn't you agree that it is wrong? Negatives. Like what's 4 minus -5? 9. I can plug in -5 as well. So wouldn't you agree that it's all numbers from -infinity all the way up to 4, including 4? That's the domain. Very simple. Now let's think about when we plug in those values. This is one way to find out what range is. Look at the domain, plug in a couple, and see what happens, especially in this case. When I plug in 4, what do I get for a range value? 5. Now, when I plug in 3, what's 4 minus 3, everybody? 1. What's the square root of 1? Just move your lips. 1. What's 5 plus 1? 6. What happens when I plug in 0 for x? What's 4 minus 0? 4. What's the square root of 4? 2. What's 5 plus 2? What is the range apparently doing as I plug in these decreasing x values? Increasing. Wouldn't you agree that it appears the range is going from 5 off to infinity? Remember that -5 I said? What's 4 minus negative 5? 9. What's the square root of 9? 3 plus 5 is what? Again, increasing. It's getting bigger. The bigger the negative I put for x in, the bigger the positive I get for y. Okay, blah, blah, blah. It's kind of mathematically incorrect what I said there. Or, you can go and snap this on a graphing calculator. And it does make me sad, people that don't understand this. The domain and range is staring you in the face right now. Look at this. What do you think that is for an x value right there? 4. And then does 3 comma exist? 2 comma? Negative comma? So all of these x values exist on the graph. And lo and behold, all of these y values exist on the graphing calculator. What do you think this y value is? 5. So that's another very valid way to assess domain and range. No student should have a problem with that. Get that head up. No sleeping in my class. Okay, now I put that down here in a way that would make sense out of that, but you can go ahead and read that. How to do range is actually a problem. It is a little bit tough. You know what? I think I'll stop there, even though in the other class I started yammering about this number 20. So, look at what I got up to. Number 18. The assignment, I think, goes up to 23. You should be able to do 3/4 or more of your assignment tonight. No problems. And then we can pick up